Hello and welcome to the AI Research Roundup. I'm your host Alex. Today is May 6th, 2025. Alright, we're diving into this ICLR conference paper toward guidance-free AR visual generation via Condition Contrastive Alignment, which came out just over 3 months ago. So, autoregressive visual models, AR models, usually rely heavily on Classifier-Free Guidance, or CFG for quality, unlike large language models. But CFG is costly. This paper proposes Condition Contrastive Alignment, CCA, to fine-tune these AR models directly, achieving high quality without guidance. Okay, looking at some initial results here. These plots compare CCA, shown in red, against standard guidance-free generation in blue, and the costly CFG method in gray, across different LlamaGen and VAR model sizes. For both FID and IS metrics, CCA dramatically boosts the guidance-free quality. It brings it really close to the guided performance, which is quite impressive after just one epoch of tuning, effectively bridging that gap we talked about. Okay, so how does CCA achieve this improvement? Figure 2 illustrates the method. It starts with training data, specifically matched image label pairs treated as positive examples. Then, it creates negative examples by randomly pairing images with incorrect labels from the batch. The CCA process then fine-tunes the pre-trained model by contrasting these positive and negative samples using a specific alignment loss. This essentially teaches the model that, quote, conditional residual needed for high-quality, guidance-free results. Building on how CCA works, this table really summarizes its advantages compared to traditional guidance methods. Okay, it lays out classifier guidance, classifier-free guidance, and CCA side by side, comparing their modeling goals, training losses, and sampling policies. But look at the bottom rows. The costs. CCA needs just about 1% extra training cost versus 9 to 10% for the others. And crucially, its sampling cost is 1x, effectively halving the 2x cost associated with CFG. And these visual results really drive home the point. Figure 3 shows sample images generated by LlamaGen and VAR. Okay, you can see the difference clearly. The leftmost column, without guidance, has lower quality, but the middle column, using CCA without guidance, looks dramatically better. The visual fidelity, backed up by those IS scores, gets really close to the expensive CFG method shown on the right. It's a striking improvement. Okay. And backing up those visual improvements, Table 2 provides a broader comparison on the ImageNet benchmark. It shows different model types, diffusion, mask, and autoregressive, comparing their performance with and without guidance using metrics like FID and IS. Well, focusing on the AR models, adding CCA to LlamaGen and VAR dramatically boosts the without guidance scores. Look at VAR plus CCA, achieving a record guidance-free FID of 2.54. It really reinforces CCA's effectiveness quantitatively. Following those quantitative results, these plots dig into the trade-offs a bit more. Okay, they show FID versus IS for LlamaGen and VAR. The red line represents CCA, while blue is CFG. By adjusting a training parameter, Lambda CCA traces a very similar performance curve to CFG, which adjusts its guidance scale, S. This means CCA offers comparable control over the diversity fidelity balance, but without that extra sampling cost we keep mentioning. Okay, so wrapping things up, we've seen CCA provides that same kind of quality control as CFG, but much more efficiently. It really seems like a major step forward for autoregressive visual models, achieving high-quality results without guidance, and crucially, halving that sampling cost. It effectively brings LLM alignment ideas to vision generation. Alright, that's all for this week's AI Research Roundup. Thanks for tuning in. I'm Alex.